Okay, so chromatography we have done already. In O levels, we saw कि chromatography क्या होती है और कैसे होती है. But how is this one in A levels different? So the idea is that we want to understand how chromatography is done, and then उससे हमें वो जो पहले हम करते थे liquid वाली chromatography वो भी समझ आ जाएगी. So there are two main categories of chromatography that we are going to look at. The first one is TLC, thin layer chromatography. अच्छा, अब इसमें हम करते क्या हैं? हम बहुत छोटा सा एग्जाम्पल लेते हैं. जैसे कि आपको याद होगा कि आपने इंक की एक क्रोमेटोग्राफी की थी किसी जमाने में. So that chromatography is kind of like this. And we take this, we mix them, and that mixture is separated based on this. अब उसमें होता क्या है? Chromatography में दो parts होते हैं. One we call stationary, because that's the part that doesn't move. And the other one we call mobile, because that's the part that actually moves. So what exactly is the stationary part? This is the part that has a surface on which the mixture will stay. And mixture will make bonds with this surface. And that process is called adsorption. So the stationary part, or the stationary layer, or stationary phase, which we call it, it provides a surface which offers adsorption. Usually हम alumina use करते हैं या silica use करते हैं. क्यों? Because we need a surface on which is rough, which offers a large surface area on which the thing can like make bonds with and get adsorbed. Okay. अब होगा क्या? If the substance, whatever we are moving on to the जिसकी chromatography हम कर रहे हैं, if it makes strong bonds with this, तो it will travel less distance to the top. So अगर हमारे पास ऐसे है और stationary part के साथ उसका strong bond बनी है, so then it will move lesser distances. ठीक है? So that all depends on कि उसकी absorption के साथ जो हुई है वो कितनी strong है. So we can say कि it's kind of like the substance sticks to the surface, and if it sticks more, then it moves less distance. So if these forces are bonds are stronger, less distance moved. Okay. So this is kind of the part that slows the movement through adsorption. Dusra mobile, as the name suggests, it flows. Okay. And it dissolves the thing and it forms hydrogen bond with it, or it forms permanent dipole या temporary dipole. कोई ना कोई dipole form करता है ये उस substance के साथ जिसकी भी हम chromatography कर रहे हैं. And it makes it move upwards. Okay. So it uses van der Waals forces to move or dissolve the chromatography वाला जो भी substance है. So chromatography is basically a fight between which one, stationary या mobile, which one wins the tug of war. That's it. Now, of course, अगर color होगा तो बड़ा आसान है, वो ऊपर जाएगा, हमें नजर आ जाएगा. अगर color नहीं होएगा तो we will need to use some locating agents. So locating agents or ultraviolet light is used to identify colorless substances. ठीक है? So ये तो हम देख ही चुके हैं O levels में. So in O levels, what was your stationary part?
The filter paper.
The filter paper, yeah. And the mobile part was water or alcohol, whatever solvent you used. And it was able to form bonds, van der Waals forces with the ink particles, and ink particles were able to adsorb on the surface of that filter paper. Okay, so just like over there, we will still have a chromatogram like this. We will still have a baseline, and we need to make sure that this baseline is drawn with pencil. Okay. Then we will again put a spot on the baseline. This spot will be then this substance will be dipped into the solvent, making sure the mobile phase, making sure that the spot and the baseline is above the solvent. Okay. And then the solvent will move up, making bonds with this, making it go with it. But at the same time, because this surface is coated with the stationary phase, the surface will try to make absorb this substance. Whatever it absorbed more will stay towards the lower half. Whatever forms stronger van der Waals forces will go towards the top half. And that is how these mixtures will go. Why will multiple spots appear? Because each substance has a different level of chromatogram या जो भी वो absorption करता है. We have to make sure that we stop the reaction before everything reaches the top. Why? Because we need to have the solvent front. Now, if there's a substance that forms the same level of adsorption and van der Waals forces, because again, it's a tug of war. So, अगर इसका और इसका van der Waals forces भी एक जितने हैं, adsorption भी एक जितनी है, तो ये एक ही distance पे travel करेंगे. And we will say that they are the same identical substance. And we will calculate RF value to do that. So इसकी RF value क्या होगी? Distance from here to here divided by distance from here to here. ठीक है? अच्छा मुझे बताएं. Yeah.
इसके अंदर the stationary thing, it won't be the filter paper, right? It will be like aluminium वाला जो आपने बताया.
Yeah, if we have, because we are not using a filter paper here, we are using a very thin layer of some material जिसके ऊपर हमने coating की हुई है Al2O3 की या SiO2 की. वो जो भी चीज होगी, मतलब ये जो लेयर है ना, ये जो भी चीज है, whether coating की है या नहीं की, this is the stationary phase. Okay?
Yep, got it. Thank you.
Yep. And again, you can clearly see कि ये जो हमारा stationary phase है ना, ये भी काफी polar है. So most of the time, many polar things stay towards the bottom and non-polar things usually go towards up. ठीक है? So हमें इससे पता चल जाता है. Get it? So tell me, if I asked you a question, why does it split up? Because it's impure. That's why.
Oh, okay. Could we say it's made of different like pigments
Substances?
and they travel at different like
Yeah, of
rate?
course. They have different RF values. Yes, you can say that. Acha. We'll use the same ideas, and this time we are going to do the GL chromatography. The GL chromatography is basically the gas liquid chromatography. I think I messed up the spelling somewhere. In the GLC, a gas liquid chromatography, you have, what you do is that you vaporize something and you take the vapor जिसको आप एनालाइज करते हो, जिसको आप देखते हो. ठीक है? अब इसमें हम क्या करते हैं? सबसे पहले हम इस सब्सटेंस को, जिसको भी हमने एनालाइज करना है ना, उसको हम इवेपोरेट कर देते हैं. So we usually take things that are easy to evaporate. For example, we take gases, we take volatile liquids, we take vapors of solid, and this is what we're going to test or analyze here. All right. What is our stationary phase? Stationary phase हमारा क्या होता है कि हम कोई एक ऐसी सरफेस रखते हैं जिसके ऊपर ये पार्टिकल्स आकर बॉन्ड कर जाए. ठीक है? सो हम एक ऐसे करके एक स्टेशनरी फेज रखेंगे. इट कैन बी सिलिकॉन डाइऑक्साइड, अगेन इट कैन बी ग्लास, इट कैन बी अ वेरी बिग मॉलिक्यूल जो कि जिसका बॉइलिंग पॉइंट इतना ज्यादा है कि इवन इफ यू आर यूजिंग अ वेपराइज सॉलिड वो बॉयल ना हो और वो बस इस सरफेस के ऊपर पड़ा रहे वो मॉलिक्यूल. इट कैन बी लाइक वैक्स की कोटिंग कर सकते हैं हम इसके ऊपर. वैक्स इज अ हाइड्रोकार्बन बट उसका बॉइलिंग पॉइंट बहुत हाई होता है, तो हम उसको यूज कर सकते हैं. दैट्स द स्टेशनरी phase that we have. And then we make this thing travel in currents of inert gases. So our mobile phase is inert gas. Inert gas, अगर आपका budget low है या आपका temperature low है तो you can use nitrogen. But अगर temperature high है तो we could use argon, we could use helium. ठीक है? This gas will make this thing move along this long surface. And because it's at the molecular level, तो long का मतलब ये नहीं है कि वो 6 meters की होगी. Long का simply मतलब ये है कि compared to each other, the stationary phase has a strong, what you call, strong, uh, like a large surface area. Now, of course, these are vapors, and this is also vapor. तो होता क्या है? आपका डिटेक्टर यहाँ पे होता है. So रास्ते में this stationary phase slows this down. Whatever is coming out, whatever vapors are coming in, the stationary part is going to try to form bonds with it, and it's going to slow it down. Okay? Do you get it? कि हमारे पास, as this gas makes it move along the surface, it is possible that this vapor or whatever this is makes bond with it and it slows down along the process. और हमारा जो डिटेक्टर है वो डिटेक्टर तक थोड़ा लेट पहुंचेगी. This is called retention time. So we say that the retention time is time taken for anything to reach the detector. Okay? Time taken to travel through the column to the detector. Of course, this time taken depends on the constant variable. The control variable is the flow of this inert gas, but it depends on the MR of that thing. It also depends on the kind of bonding that that thing has, और उसकी वजह से retention time हमारा change होता है.
Sir,
सही है? Yes.
sir, will retention time exist in TLS? TLC, sorry.
TLC में we don't time it. We just measure the distance. Here we time the thing क्योंकि इसमें eventually everything is going to go towards the detector. और by the way ये होता है ऐसे long column है तो उसमें जरूरी नहीं है कि वो लेटा हो इस तरह से, horizontal होना जरूरी नहीं है. But we can still set it up like that. And eventually उसने यहाँ पे पहुंचना ही पहुंचना because it's a gas and the gases will flow. Diffuse तो वो करेगा ही करेगा. बीच में वो slow down हो जाता है because of the stationary phase.
Sir, but why do we
इसमें उस
time it? Like, what's the
because देखो
purpose of timing it?
we just want to know that in this one we are saying कि अच्छा they are all traveling but some are traveling more distances than some that are traveling less distance, and based on that we can figure out which one is what. Over here they're all traveling but one is traveling faster than the other even though the mobile phase is moving at the same speed. Why is one faster than the other? Maybe because one is lighter than the other,
Oh,
right?
sir, so basically we're trying to figure out कि like gas किन different gases से बनी हुई है.
Yes. So ये गैस की बेस पे कर रहे हैं क्योंकि इसने गैस है, इसने पहुंचना तो है ही. यहां पे इसने जरूरी नहीं था कि ये कभी यहां पे पहुंचता, लेकिन ये वाला तो पहुंचेगा ही पहुंचेगा हर सूरत. Clear?
Yep, thank you.
Okay. So we take the retention time and based on the retention time, sorry, based on the retention time के उसको कितना वक्त लगा है GLC कॉलम में से गुजर के डिटेक्टर तक पहुंचने में, we are able to figure out कि अच्छा, first of all the detector will tell us कितने मिक्सचर्स थे. कैसे? जैसे यहाँ पे हमें स्पॉट नजर आ रहे हैं ना, वहां पे हमें पीक्स नजर आएंगी. हमारे पास एक ग्राफ बन के आएगा और उस ग्राफ पे डिफरेंट पीक्स होंगी. हो सकता है वो पीक्स डिफरेंट हाइट की हों बट वो इस तरह से पीक्स होंगी. और ये पीक्स हमें क्या बता रही हैं कि यहाँ पे टाइम है, ठीक है, मिनट्स में हो सकता है, सेकंड्स में हो सकता है. ये जीरो का मतलब है जहां पे आपने उसे ऑन किया, स्टार्ट किया, ठीक है. और हाइट को एज सच वी विल नॉट कंसिडर एट द मोमेंट. We will just see that because we are having 5 different peaks, each peak is telling me about 5 things, and this one has the highest MR or also the strongest bonds that it made, and this one is usually the lightest of all of these. Okay, तो हमें यहां से ये पता चल जाता है. Now another important point here to remember, the peaks tell us the story of each individual molecule that you have. Okay, and the area of each peak tells me which is present in higher quantity. ठीक है, so what we do is we are like इन सबका area calculate करेंगे. ये सारी triangles बनती है ना, we will assume them to be triangles. So ये सब triangles का area हम add करते जाएंगे and we will divide individual area by the total area. Okay, so each peak's area divided by total area times 100% tells me कि अच्छा ये वाला कितना proportion exist करता था. Percentage composition कह लो इसको आप, कि अगर मैं कहूं कि total area आता है 10 और इसका area है 1 तो ये 10% of the total है, और इसका area आता है 3.2 तो ये 32% of the total है. ओके, तो मिक्सचर की composition कितने परसेंट क्या है वो भी we are able to figure out from here. Again, just to gauge which one will have lower retention, of course MR plays a role, but van der Waals forces also play a role. If something is heavier तो obviously वो late आएगी, but साथ ही साथ if it is very non-polar तो तब भी इसका आने का चांस ज्यादा है. क्यों? If it is non-polar, the stationary phase will also attract it more. तो वो slow down ज्यादा होगी. If it is polar, it will create dipoles in the argon or whatever gas you're using, nitrogen for example. और उसके साथ इसकी strong bonds बनेंगी और ये जल्दी flow करेगा. So polar चीजें इस side पे होती हैं या lower MR वाली चीजें इस side पे होती हैं, और higher MR वाली चीजें या stronger London dispersion वाली चीजें on the higher retention time होती हैं.
Sir, you said something like, what does the height show of these peaks?
Height helps us figure out the area because each one of these is a triangle, right? So we take the area of each triangle, we divide it by the total area, and that gives us the percentage composition.
Got it. Thank you.
इसका फायदा बहुत है. For example, you take Milo for example, and you vaporize Milo. एक ड्रॉप लेते हैं, उसको वेपराइज करते हैं और उसकी GLC करते हैं. हमें अगर पता है ना कि किस चीज का कहाँ कितना रिटेंशन टाइम होता है, इफ वी हैव द इंग्रेडिएंट लिस्ट ऑफ माइलो और हमें हर चीज का पता है कि इसका रिटेंशन टाइम कितना होता है गूगल करके, तो वी कैन फिगर आउट कि अच्छा माइलो में शुगर कितने परसेंट है, वाटर कितने परसेंट है, कोको पाउडर कितने परसेंट है, या जो भी चीज़ें वो कितने परसेंट है, क्योंकि उनके पीक्स के एरियाज डिफरेंट होंगे और टोटल 100% होता है. ठीक है, सो इट अलाउज अस टू फिगर आउट द कंपोजिशन ऑफ unknown mixtures. Okay, so two techniques of chromatography, one depends time taken and one depends on the distance traveled, and that's it. That is chromatography.